Hello guys, welcome to another video of mine. Today we'll start trigonometry. The word trigonometry comes from Greek where tri means three, gonus means sides, and metry means measurement. And as the name suggests, trigonometry mostly deals with triangles and the relationship between angles and sides of a triangle. So in this chapter we will use a lot of Greek words or symbols like theta, alpha, beta, gamma. So get used to them. The triangles will be right angle triangles which come in all shapes and sizes. And now let us assume a right angle triangle which is right angle at B, and let us assume angle A will be theta. Okay. Now in this triangle ABC, okay, now in this triangle ABC, the side opposite to the right angle will be hypotenuse, and the side adjacent to angle theta is the adjacent side, and the side opposite to BC and the side opposite to theta is BC. So based on these definitions, we will introduce some trigonometric ratios, the standard trigonometric ratios. Okay. Sine A is opposite side by hypotenuse. These will be like the standard definitions, so you just have to know them. And next is cos A is adjacent side of theta by hypotenuse. And similarly, we have tan theta, which is opposite side by adjacent side, and next cot theta, adjacent side by opposite side, secant theta, hypotenuse by adjacent side, and cosecant theta, which is hypotenuse by opposite side. This is actually boring, but yeah. Okay, these are like the standard definitions. You just have to remember. These are the basics. Okay, and you know this guy from Demon Slayer, one of my favorites. You know what he does when he's stuck after 6 months of intense training, he'll just come back to the basics and start from the beginning. In the same way, you should also do the same. Don't forget the basics, okay? Now imagine you are lying in your backyard and looking at the top of the tree, and you wanted to find the height of the tree. Let us assume the height of the tree is h, and your viewing angle becomes the hypotenuse, and the angle itself is theta. So now this forms a right angle triangle, and the distance between you and the tree is d. So yeah, now we have created a right angle triangle with angle theta, and we have the height, the distance, and theta. What do you think is the best, or what do you think the appropriate trigonometric ratio we use here? We have the viewing angle theta and the opposite side h and the adjacent side d. So the best would be, I think, tan theta, which is height by distance, height of the tree by distance between. So tan of theta is height by distance. Therefore, height is equal to d tan theta. That's it. If you know the exact numericals, you can find the solution. Before going to solve the exercise problems, you need to understand how to solve a problem. Okay. First, read and understand the question clearly. Okay, understand is a keyword here. You have to understand the question. Then draw the right figure. This almost solves half of the problem. And then relate the question to what you already know. Okay, like how I told to remember those basic trigonometric ratios. And that's how you need to remember. And finally, you can just reduce the problem to simpler terms and you can solve it easily. We'll go to exercise 8.1. In the first question, we are given a triangle ABC where B is the right angle and AB is 24 and BC is 7. Now we just have to find sine of A and cos of A. Yeah. Now sine A is given by as we know from the definition, opposite side by hypotenuse. Here opposite side is BC by hypotenuse AC. So, but we don't know what AC is here. Okay, we need to find that. And similarly, cos A is adjacent side 24 BAV by AC. So to find AC, We use the age-old Pythagoras theorem. From Pythagoras theorem, as we know, AC, AC square is equal to square of hypotenuse is equal to sum of squares of the other two sides. From this, we get that AC square is equal to AB square plus BC square. So that would be 24 square plus 7 square. On this, we get AC is 25. Okay. Now we will solve sine A, which is sine A is equal to BC 7 by hypotenuse 25, and cos A is adjacent side 24 by 25. That's it. Simple. Come on, we'll go to the next question. So here we are given a triangle PQR where Q is the right angle and PQ is 12 and hypotenuse PR is 13. We have to find tan P minus cot R. Cool. Okay. Okay, now back to the definitions. Okay, we'll use Pythagoras theorem to find the other side first. So here PR square is equal to PQ square plus QR square, or PQ square plus QR square is equal to PR square. PQ is 12 and PR is 13. So from this we will get that QR square is equal to 13 square minus 12 square, which is 5. Okay. Now we have all the three sides. Now it's very easy to just note down to give the ratios, which is tan P is opposite side by adjacent side, so 5 by 12, and cot R is QR by PQ, which is 5 by 12. So tan P minus cot R is 0. Okay, so we'll go to the next question. So we are given secant theta is equal to 13 by 12, and we have to find all the other trigonometric ratios. Yeah, it's interesting. First things first. What did I tell you? Basics. Don't forget the basics. So let's first draw the right angle triangle, okay? This chapter all we do is draw the right angle triangle, and almost half of the problem is solved. So assume a triangle ABC and take any of the two angles A or C as theta, but not B because that is a right angle, okay? And now secant theta is 13 by 12, which is secant of A, let us assume. Secant is hypotenuse by adjacent side, so it is AC by AB. Now we can directly assume 13 and 12 as the sides as AC or AB, but for general purpose, we'll assume a constant K such that 13K and 12K are the actual sides, okay? So AC is 13K hypotenuse and AB, the adjacent side, is 12K, and to, using Pythagoras theorem, we'll find BC. So AC square is equal to BC square plus AB square. From this we'll get BC is equal to 5K. Actually these are the standard Pythagoras triplets, if you know, 5, 12 and 13 in the same way 7, 24, 25 from the previous problem. Yeah. So from this we have all the sides. Now it's just a matter of seconds to get the answer. So sine theta is BC by AC hypotenuse. Okay, so that is 5 by 5K by 13K or 5 by 13. Similarly, cos theta is adjacent side AB by hypotenuse. So that will be 12K by 13K. Now, tan theta is opposite side BC by AB. So that will be 5 by 12. Next, cot theta, which is 12 by 5. Basically, if you know one trigonometric ratio, you can find all the other, like how we did in this problem. But there is still, you can still simplify it. If you are now going to the next question, here we are given angle A and angle B are acute angles such that cos A is equal to cos B. Now we will draw two triangles, two right angle triangles. One is A. We just will just name the sides which we want, A and B. Okay. Now given that angle A is equal to angle B, but even to simplify the problem, actually in the question we are not given this is on the same triangle, but we can still assume it because there is nothing wrong in that, and it still satisfies all the given conditions, which is angle A and angle B are acute angles. So we'll just simplify this to just one triangle. Okay, ABC maybe, and angle A is equal to angle B. Okay, we have to prove that angle A is equal to angle B. So we are given cos A is and cos B are equal. What is cos A? Adjacent side by hypotenuse from the trigonometric ratios definition. So here adjacent side is AC by hypotenuse AB, which is equal to cos B, which is adjacent side BC by AB. So this simplifies to AC is equal to BC. That means that the two sides are equal. The two sides are equal, that is an isosceles triangle, and the opposite angles of those two sides will also be equal. This is the property of isosceles triangle. Okay. So from this we'll get that angle CAB is equal to angle CBA. In short, angle A is equal to angle B. These are such simple problems. Okay, if you just know the definitions, you can solve these problems in matter of seconds. Okay. The other problems in this exercise are similar to these, which are simple. Now let's just go directly to the 10th problem. So in triangle PQR, which is right angled at Q, given that PR plus QR is 25 and PQ is 5. So let us first draw the triangle. Angle Q is right angle and PQ is 5 centimeters and PR plus QR is 25. Okay. Okay, now we'll use the Pythagoras theorem again. So PQ square plus QR square is equal to PR square. So 10th class students, when you are solving problem, just remember you have to write the problem clearly. Okay. So PQ square plus QR square is PR square. PQ square is PR square minus QR square. So we can write A square minus B square as A plus B into A minus B from algebra, maybe. So we already know PR plus QR as 25, right? So PQ is 5. So 5 square is 25 and PR square 25 PR minus QR. Now we know PR plus QR is 25. Solving both equations, we will get 2 PR is equal to 26. Therefore, PR is 13. If PR is 13, then QR will be 12. 12. 12 plus 13 is 26. 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 12 plus So now we got the Pythagoras triplet as the triangles, as the sides of the triangle, which is PQR, 5, 12, and 13. Now we will find sine P, cos P, and tan P. So sine P is opposite side QR by hypotenuse PR. So that will be 12 by 13. And cos P is adjacent side 5 by 13. And tan P is opposite side 12 by 5. That's it. Okay, now we'll we will define something, okay, or we will come to a clarity. So here we have sine, cos, and tan. From this we can, as I told you, from the triangle, if you draw a triangle, we can get the other three ratios. But we can simplify this even more. Okay, you see from the problem, tan theta is sine by cos. Similarly, cot theta is cos by sine, which is the inverse of tan. Okay, and secant theta is 1 by cos, that is reverse of cos, and cosecant theta is 1 by sine theta. That's it. This simplifies even more without even looking at the figure, okay? So if you know sine theta and cos theta, you don't even need to draw the figure. You can directly solve the problem. Now we will come to trigonometric ratios of specific angles. Okay, so these are the specific angles: 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So these are like the standard acute angles, and you have to remember the ratios of these specific angles to simplify the problems much faster. If you can't remember them, it just takes another 2 minutes. But in competitive exams or near CBSE board exams, time is crucial. So with enough practice, you can just remember all these without even trying to by heart them. That's it. So keep rocking. Now first we will solve for 45 degrees. Okay, we'll find the trigonometric ratios of 45 degrees angle. Where do you find 45 degrees? I would say if one angle is 45, from sum of angles of triangle, we can get the other angle is also 45. So that makes this an isosceles triangle. So now we will assume the sides as A and A, the adjacent sides, and the hypotenuse will be from Pythagoras theorem, A square plus A square under root. So that will be root 2A. Now sine of 45 degrees, you can take any angle either B or C, it's the same since it is an isosceles triangle. So we'll take sine B, sine 45 is adjacent side AB, sorry, sine opposite side AC by hypotenuse BC. So it is A by root A, root 2A, that is 1 by root 2, and similarly cos 45 is also adjacent side AB, A by root 2A, that is 1 by root 2, and tan 45 as we have told earlier, sine by cos, which is 1. Cosecant 45. Now we will come, okay, now cosecant 45 is root 2 and secant 45 is 1 by cos theta, that is root 2, and cot theta is inverse of tan, so that will still 1. So these are standard ratios for 45 degrees. Next we will see 30 and 60 degrees respectively. Where do we find 60 degrees in a triangle? So now in the triangle A, so now we will assume an equilateral triangle ABC, where each side is 60 degrees. Now we will draw a perpendicular AD onto BC. So it divides angle A as 30 degrees and 30 degrees. Now we have two triangles with side A and 30 and 60 degrees in the same triangle. Okay. Now we'll find the ratios. Now sine B. To find sine B, we need to know the opposite side AD. So in triangle ABD, we have hypotenuse AB square is equal to BD square plus AD square. So now we'll get AD as root of AB square, which is A square minus BD square, A by 2 square. That will be root 3 by 2 of A. Now we will find the ratios of 60 degrees. Sine 60 is opposite side AD by hypotenuse AB. So that is root 3 by 2 A by A. That is root 3 by 2. Similarly, cos 60 is given as adjacent side BD by AB. That is 1 by 2. And tan 60 opposite side by adjacent side, which is root 3 by 2A by root 3 by 2. So that becomes root 3. From sine, we can get cosecant 60 as inverse of sine, that is 2 by root 3. And from cos, we will get secant theta as 2. From tan 60, we will get cot 60 as 1 by root 3. Okay, now we'll use the same triangle to find the trigonometric ratios of 30 degrees. So sine 30 is opposite side BD by hypotenuse AB, which is A by 2 by A. I'm assuming triangle ABD here. Okay, A by 2 by A. So that is 1 by 2. Cos 30 is adjacent side AD by hypotenuse AB. So that will be root 3 by 2A by A. That is root 3 by 2. Tan 30 is given as opposite side by adjacent side. So that is 1 by root 3. From this we will get cosecant as cosecant 30 is 2. From cos we will get secant as 2 by root 3. And from cot we will get cot 30 as root 3. That's it. These are the standard ratios for 30 and 60. Now to find the ratios of 0 and 90, we will assume a triangle ABC and C is the angle we want. Now imagine this angle is around 60 degrees or something. Now we will reduce the angle a little by little till it gets 0. Okay, just use your imagination here. So assuming angle C is around 60 or something, 60 or 70, we slowly decrease the angle. So imagine this is 45. Did you observe that side AB is also decreasing? Now assume the angle is 30 or something. Angle A, side AB is still reduced now. So as you see, as AC is approaching BC, side AB is decreasing and angle C is becoming 0. So when angle C is 0, AB is also 0, the side AB, and AC coincides with BC. So now we will find the sine of angle C, which is 0 degrees. So this is still a triangle, if you can imagine. So sine 0 is sine C is opposite side. Here opposite side was AB by hypotenuse AC. But here side AB is 0 by hypotenuse AC. So 0 by something is still 0. and cos 0 is adjacent side, which is BC by AC. Here both are equal in this case. So BC by AC is 1. So sine 0, cos 0 is 1, and sine 0 is, oh sorry, that's not 0 degree, that's a 0. Sine 0 is 0 and cos 0 is 1. And now tan. Tan is opposite side by adjacent side, AB by AC, AB by BC. So that's still 0, or sine by cos is 0. Now the interesting part, cosecant of 0, which is 1 by 0. So 1 by 0 is, as we know, division by 0 is undefined. So cosecant 0 is undefined. And cos 0 is, and secant 0 is 1 by cos, that is 1 by 1, if it's still 1. Okay. And cot 0 from, we'll get it from tan, which is still 1 by 0. So cot 0 is also undefined. Okay.
So now in the triangle ABC, we have assumed angle C is 0, right? So what is the other angle? Angle A becomes 90 degrees. Theoretically it becomes 90 degrees because sum of angles is still 180, right? B is already a right angle, and now A is also 90 degrees. Theoretically we cannot draw it in real time. So now we'll take the sine of angle A. Therefore angle sine of A is BC by AC, which is sine 90 is 1, cos 90 is adjacent side 0, AB by AC, which is 0, and tan 90 is opposite side BC by adjacent side AB, which is BC by 0, which is undefined. And from sine we can get cosecant 90 as 1, and cos 9 and secant 90 from cos, which is 1 by 0, it is again undefined. And finally cot 0, which is AB by BC, so that will be 0. So this is how we get standard trigonometric ratios. So you can see it on the screen. Thanks for watching. Please subscribe.